everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from Laplace Transform. So let's get going. Problem: find L of t square e power minus t cos t. So here we have t square, e power minus t and cos t. Okay. So finally, at the end, we are going to use first shifting theorem. You can just find first Laplace transform of cos t and then e power minus t cos t, and later you can go for t square e power minus t cos t. But here, for my convenience, what I'm going to do is I'll just first find L of cos t and then I'll find t square cos t, and then we'll go for e power minus t square cos t. Let's see how I'm going to do here. Now I'll find L of cos t. Since we know that L of cos at equal to s by s square plus a square, just compare cos t with cos at, then for a equal to 1 we'll have L of cos t equal to s by s square plus 1 square, which is equal to s by s square plus 1, right? Now I'll find L of, that is Laplace transform of t square cos t. Okay, I'm going to apply this formula. Okay, if L of f of t equal to f of s, then L of t power n into f of t equal to minus 1 power n for n equal to 2 into d power n by ds power n into L of f of t, that is L of cos t. Clear? This gives us minus 1 square is 1, that is 1. You don't need to write. D square by ds square into, we know that L of cos t is s by s square plus 1. Now we'll find its derivative. First derivative. Using u by v whole prime formula, you'll get derivative of s with respect to s is 1 into s square plus 1 minus s into derivative of s square plus 1 with respect to s is 2s, right, by s square plus 1 whole square is equal to d by ds of 1 into s square plus 1 is s square plus 1 minus s into 2s is 2s square by s square plus 1 whole square, right? This gives us d by ds of s square minus 2s square is minus s square, right? So you'll get 1 minus 2s square minus 2s square plus s square gives minus s square by s square plus 1 whole square, right? Now again we are going to apply this formula. So derivative of 1 minus s square is minus 2s into s square plus 1 whole square minus 1 minus s square into derivative of s square plus 1 whole square is 2 into s square minus 1 into inner derivative. Derivative of s square with respect to s is 2s plus derivative of 1 with respect to s is 0. So you get 2s by s square, this term whole square. Okay, v square is equal to, now take s square plus 1 common from the numerator. You'll get s square plus 1, just 1 s square plus 1 from these two terms. Okay, you'll get s square plus 1 into minus 2s times 1 s square plus 1 minus, we'll just take this common, right? So you'll get 1 minus s square into 2 into 2s, that is 4s. 1 minus s square into 2 into s gives 4s, right? S square plus 1 power 4. We know that a power m whole power n equal to a power m into n, right? Likewise, s square plus 1 whole square raised to power 2 can be written as s square plus 1 power 2 into 2, which gives us s square plus 1 power 4, right? Fine. Now this gives us Now just cancel 1s square plus 1 from the numerator and also from the denominator. You'll get minus 2s into s square is minus 2s cube, minus into plus, minus 2s into 1, 2s, minus 1 into 4s is 4s, minus into minus plus s square into 4s is 4s cube by s square plus 1 whole cube, because we have cancelled 1 s square plus 1 from the numerator and the denominator, right? This gives us minus 2s cube plus 4s cube gives 2s cube, minus 2s minus 4s gives minus 6s by s square plus 1 whole cube. Okay. So we got L of cos t equal to this and L of t square cos t equal to this, right? Now we are going to apply first shifting theorem. That is, if L of f of t equal to f of s, say f of s equal to this one, then L of e power minus at into f of t equal to f of s plus a, right? So now we are going to find L of e power minus t, t square cos t, e power at into f of t equal to f of s. You have 1 here for a equal to 1. Just compare this with this formula. Then for a equal to 1, you'll have f of s plus 1 here, right? So if f of s equal to 2s cube minus 6s by s square plus 1 whole cube, then f of s plus 1 will be, just replace s by s plus 1, you'll get 2 times s plus 1 whole cube minus 6 times s plus 1 by s plus 1 whole square plus 1 whole cube, right? So you'll get equal to 2 times s plus 1 whole cube minus 6 times s plus 1 by s plus 1 whole square plus 1 whole cube. Okay, first of all you have to observe the question. Here you have cos t, e power minus t, t square. You have multiplication by powers of t, right, which is t square. And you have e power minus t. So you have to calculate in mind. Okay, for that you need to practice. So just keep these two formulas in mind before solving the problem. Okay, then you'll get the idea. If you want, you can simplify it or just leave it. Therefore, L of, see this I wrote to, I just want you to understand, so that I wrote the question like this, okay? So L of t square e power minus t cos t equal to 2 times s plus 1 whole cube minus 6 times s plus 1 by s plus 1 whole square plus 1 whole cube. This completes the problem. First, we'll find L of cos t, and then we'll use multiplication by powers of t to find t square cos t, because it is easy. If you can find e power minus t cos t, you can go for it. There's nothing wrong in it, okay? You can first find cos t and then you can find L of, see, first find L of cos t and then you can find L of e power minus t cos t using first shifting theorem, and then you can go for t square into e power minus t cos t using multiplication by powers of t by considering e power minus t cos t as your f of t, and here 2 will be the power. Okay, you can just apply in the formula and you can just find it out. Okay, but while finding first shifting theorem, by using first shifting theorem, you'll get s plus 1. So here you may need to find its derivative, right? We'll be finding derivative here. So this s plus 1 may trouble you. So for that purpose, in order to make things easier, I just go like this. If you want, you can try. Fine. Well, we have seen a problem from Laplace transform in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.